Let's go ahead now and let's look at question B. For part B, it says, revise your model so the reflector is at the bottommost position at time equals 0. So now what's changing is our starting position. Our starting position is no longer at the top like it was in the first part. Instead, it's starting at the bottommost position. So I'm going to go ahead and once again, I'm going to shade in red right here where the reflector is, the one that we are talking about, so that you don't get confused with the top one. In this particular case, what is going to be the height of the reflector at the very beginning? If this is the ground right here, the information hasn't changed. The radius, which means from the center going all the way down to the ground, is 30 centimeters. From the reflector, okay, to the center, that distance is 17. So that means that from the reflector going down, that's going to be 13, okay? So then in this particular case, I'm going to do the same thing I did before. I'm going to see if we can do it a little bit faster now that you're catching on. We have time versus height. So we have 0, 1, 2, 3, 4. That's because this is happening in 4 seconds. At time 0, remember we're starting at the bottom. So the height at time 0 is going to be 13. After 1 second, since this is moving clockwise, the reflector is going to shift and it's going to be basically right here. At this point, what is going to be the height off the ground? In this case, it's going to be back to being 30. Then the reflector is going to move all the way here to the top. Once it gets to the top, what is going to happen? What is going to be the height? The height is going to be 47. Then the reflector is going to move again back onto the right-hand side. What is going to be the height at that point? It's going to be 30. And then back at the bottom, it's going to go. And once it reaches back at the bottom, it's going to be back to being 13. Okay, so these are basically the points of what's happening in this second situation. I'm going to do the same thing I did before, which is I'm going to create a graph so that I can visualize what is happening and I can get a better idea as to whether I'm going to use cosine or sine to model this. Right here, I'm going to put time and this is going to be height. Let's go ahead and add the 13, 30, and 47. So here at time 0, we are at 13. At time 1, we are at 30. At time 2, we're at 47. At time 3, we're going to be at 30. And at time 4, we're going to be at 13. So what's happening with the graph is that it does resemble a cosine, but in this case, it's going to be negative cosine. Here is my principal axis. This is where I can cut the graph in half, so it is perfectly symmetrical. The amplitude is still going to be 17. So if I do 360 divided by 4, I'm going to get 90 degrees. So there's a lot of things that actually are staying the same. I'm going to get y equals, in this case, negative 17, the cosine of 90x plus 30. Once again, why is it negative? Because remember that cosine, when it's positive, it opens up. But in this case, it's opening down. And so it looks like a hill. And that means that it's going to be negative cosine. The other thing is, notice the principal axis where I can cut it in half is occurring at 30. So that is going to be my D, my vertical shift. Also, from this principal axis, I'm going up 17, down 17. So 17 is my amplitude. And because the period is equal to 4 seconds, and we know that 360 divided by B has to equal 4, then I know that it has to be divided by 90. So B is 90.